welcome back. Today we're going to do a brief introduction into memory mapped I/O using the YUP 5109 gaming subsystem. But first, before we do that, please like, subscribe, and ring the bell for notifications so you never miss another dive into the deep end of computing with the YUP 5108 virtual microcontroller. When last we visited, I showed the design of a basic 8x32 pixel monochrome video card, and today I'm going to show you how I combine 3 of these into a 24x32 pixel video screen with some LED outputs to make the YUP 5109 gaming subsystem. As mentioned before, each of the individual monochrome video cards have 32 addresses, which represent a row within each of these bands, the left, center, and right band of the display. That leaves the upper 3 bits to be used as a chip select to decide which of these devices I want to communicate with, or which one I want to write to. So as you can see, bits 0 through 4, the first 5 bits, are the address bus, and they're fed into each one of the video cards. But the upper 3 bits are fed into this decoder. And 3 bits gets you 8 possible values. So when the upper 3 bits are all 0, the 0th chip select is selected, and any write enables that come through the write enable line will be ANDed with the chip select line, meaning that only the item that is selected will see the actual write enable bit. So we can individually select each one of the devices that we want to write and enable based off of the upper bits in our address. What this provides is a memory map that allows us to select which chip we want to talk to and which chip we want to send those lower 32 values to. So with the upper bits all 0, we talk to the left band. With this 1-bit set, we talk to the center band. With a value of 2 in the upper 3 bits, we're talking to the rightmost band, and then all the values above that are talking to the individual binary coded decimal LED displays that are used for lives and score count and the like. Anytime we're talking to an address of 0, 1, 1, it doesn't matter what the lower 4 bits or 5 bits are, because there's only one location in each of these binary coded displays. We could, in theory, have included the value we want to display in the address themselves, or the individual LEDs in the address themselves. But in this case, we just have one value for each of these locations, so it doesn't really matter what the lower 5 bits are in those addresses, or address ranges. Overall, this decoder has 8 outputs. The first 3 go to the display. The next 4 go to these individual pairs of binary coded decimal displays. And then the 4th one acts as a reset line to clear everything. Now, there could be any number of different ways of putting this together and redesigning the memory map for different locations. It just made sense that the lower addresses contain the locations for the 3 bands of the screen. In a number of other systems, they'll have a much more complex memory map. In fact, the 8051 memory map had the ability to map to not just individual bytes, but individual bits within certain blocks of memory and individual bits on the I/O. So to sum up, memory mapped I/O is pretty straightforward. Basically, if you want to get to a particular device, it has a particular upper address in memory, and the items within that device would be addressed by the lower bits of the address in memory. The downside to that is that it takes away from some of your available memory for RAM or ROM, because if you only have 16 bits worth of address, then you have only 65,000 possible values. Dedicating a portion of that address space to I/O rather than RAM means you have that much less RAM and ROM. Now, in the early chips, that didn't matter. They had nowhere near 65,000 bytes of RAM or ROM, and therefore there was a lot of space in the address, in 16 bits of addressing, to get to all of the I/O locations. I wanted to reserve as many of the bytes available in the 16 bits of RAM and ROM for functional code. So I wanted to have the maximum amount of ROM and the maximum amount of RAM that 16 bits would give me. In our system, we only reserve the first 8 bytes of ROM for the reset and the interrupt vectors. So that's pretty much all I had to talk about today. I hope you enjoyed. like I said, please like and subscribe and all that fun stuff. And we'll see you next time. When last we visited, I showed 32 pixel video other memory map devices means you don't have that much memory of that